Susan Skemp, her BS in Mechanical Engineering, 1981, from Florida Atlantic University. Skemp has a broad background in industry, federal policy, and professional engineering associations. Sue Skemp joined Florida Atlantic University March 2008, Executive Director of the Southeast National Marine Renewable Energy Center. There are only 4 of them in the USA. Three. Oh, I like it. She has developed a multidisciplinary program at the university to investigate, test, and evaluate the potential of harnessing power to generate base load electricity from the ocean currents, such as the Gulf Stream, specifically ocean current hydrokinetic and ocean thermal energy conversion, led by Ms. Skemp. The SNMREC engineers, faculty, and students are making a unique contribution to a broadly diversified portfolio of renewable energy for the nation's future. I also want to point out that Ms. Skemp also served as the 121st President, 2002-2003 of the American Society of Mechanical Engineers, and is currently the Vice Chair of ASME Foundation Board of Directors. Thank you very much.
Thank you. And there are lots of gadgets up here, so we'll try to, can everybody hear me? Yes. Okay, so if I walk away, I'll get a hand signal and I'll be glad to come back to it. I'm going to walk you through a program. It's a little bit different than what you've already talked about. And think about the context of going from on land, doing a lot of unique programs and projects and moving forward in renewable energy, and take us into a different regime, which is the ocean, which covers about 70% of the Earth's surface. One other thing to keep in mind is everybody owns the ocean, nobody owns the oceans. So when you start thinking about this, there are a lot of aspects of what we've had to do in the area of ocean renewable energy, along with 2 other sister centers in the U.S., and that's the Hawaii National Center and also the center that is a partnership between Oregon State and the University of Washington. Both of those, all 3 of us, are focused on the locally available resource. So for Florida, the strength of the resource is the Florida current. For Hawaii, it's both an opportunity for ocean thermal energy conversion, which we also have that as a potential for off of the coast of Florida, but also they work on the wave energy. And then for the other center, which is off of the northwest, they're focusing on wave and tidal. But we're not only one of 3 centers in the U.S., but there's a global consortium, if you will, of looking at ocean renewable energy, because the resource itself covers 70% of the Earth's surface, as I said, and it's locally available in many countries to varying degrees, varying levels. So let me move on. That's not it. Just hit the, got it. Okay. To ground us a little bit, you've got a diagram up there of the Earth's surface, essentially flattened out. But you can see in those rectangular boxes areas around the world where the ocean current has an energy density, kinetic energy density, or a flux of at least a ½ kilowatt per meter squared. Off of the coast of Florida, that has the best potential, and that's about an average of 2 kilowatts per meter squared. So essentially in Florida, in the US, we have the greatest potential to look at the research and the evaluation of the feasibility of extracting energy from the ocean current. Also, just if you think about the ocean current in the Florida current itself, which is the Gulf Stream, the flow of the Gulf Stream between the Florida Straits, between Florida and the Bahamas, even a small portion of that feasibility or that potential is equivalent to the Turkey Point power plant, if you will. We're doing studies right now. The Department of Energy is looking at, with the help of Georgia Tech, and doing an assessment of the ocean current potential. They've done assessments on wave and tidal. They've also done assessments in the same vein on wind energy, both on land and offshore. So they're in the process that is going through an evaluation, and it should be released, if it's not already been released, in the last month. So again, we're looking at the potential. We're doing a lot of the work to determine the variability, the directionality of the ocean current as a resource. But as I will go into this next slide, this is a program, this is a focus that doesn't just only touch on the research and development opportunities for the technologies, but also the intersection in the environment. So it's really a system of systems, looking at the technology, looking at, or the technological advances, looking at the environment itself, where we will be operating, and looking at the two-way effects, the cause and effect of both of those, and wrap around that the social systems, which include not only the permits and licensing and safety and regulatory framework, but also look at, what is the viewscape? What's the public perception? So how do we, interface with all of that? We've got programs, we've got projects, we've got research evaluation, not only at Florida Atlantic University, but in collaboration globally from that perspective to understand what those intersections are and how do we work with those. If I look at this next frame, this is the timeline, if you will, to get us from an application or the first inception idea of establishing the opportunity, which was through the Department of Interior, the U.S. Department of Interior, which put out a notice of interest to the public at large, trying to determine if there was interest in pursuing ocean energy. Big picture. At that time, Florida Atlantic University did submit a letter of interest. We submitted, and we also received at that time the first infusion from the State of Florida Centers of Excellence program to the tune of $5 million to start looking at the feasibility and start defining the research areas. At that time, it was under the College of Engineering, under the Department of Ocean Engineering. Since that, because of the enormity of the program and the cross-section of those concentric circles or those intersecting circles that I showed you, it is broader than one department, one discipline in engineering, and it's broader than the College of Engineering. So we really took a focus of how to take that next level. At the same time, we started looking, because it was in the College of, or the Department of Ocean Engineering, it was housed mainly on the Dania Beach campus, and many of you may know that as also CTEC. So it was housed in that department at that facility. And so the first or initial letter of interest that was submitted to the Department of Interior was to establish a testing capability or a test site and evaluation off of the Dania Beach campus area. When we started into the regulatory process, which did not exist when we came on board and started this work, we recognized, first of all, there was no regulatory process at the federal level. The Department of Interior and the Federal Energy Regulatory Commission, at that point, were kind of duking it out as to who owned the ocean. Remember I said, nobody does, but everybody does. And it's in federal lands, so who has responsibility? So that finally, there was a memorandum of understanding to work together to establish that if you're working on the Outer Continental Shelf, which is outside the CZM or the Coastal Zone Management Area, then you fall under the jurisdiction of the Department of Interior. If you're close to shore within that CZM area, by the way, it's 3 miles on the east coast of Florida, 9 on the west coast of Florida. So if you fall within that area, then you're really working with FERC. Now, if you're working with the Department of Interior and now you're going to transmit to shore, Now FERC gets involved, along with about a dozen agencies at federal and state levels. So none of that existed. We had to pull that together and start developing a framework. At Southeast National Marine Renewable Energy Center, favorably known, or more favorably known as SNMREC, because it's easier, it's a little tongue twister anyway, we started that process and we actually submitted the first application to do the testing and evaluation, or establish a testing and evaluation site infrastructure in the water east of Dania Beach, and that was submitted in 2010. We worked through that process. An environmental assessment was necessary because of the level of the program, but we were not connecting to shore. We're not transmitting to shore, so we didn't have to go up the next level, which is an environmental impact statement. So we established with BOEM, or the Department of Interior, Bureau of Ocean Energy Management, the process to get us to this level. There were companies that were actually interested in starting to work in and do testing. They backed off until this pilot had been established, the process had been established, and then they could piggyback on what we're doing. So research is not just in the technology or in the environmental assessment, it's also in the regulatory process. And that's a tough nut to crack, believe me. And anytime I give a talk, people will ask, well, why aren't you in the water yet? Wait a minute, it's benign. You know, you're going to be out there established in an area. Well, I'll show you some of the things that had to be considered. And by the way, the environmental assessment was released finally in August of this year. So that was 3 years from the day we submitted the application. BOEM conducted the environmental assessment, so we had to deal with priorities in that agency, et cetera, that department. And then finally, we're in the process of waiting for the lease to be submitted to us so we can start negotiations on the lease. It's right now downtown in Washington, so at least it's made its way down there, and we're asking our legislators to help move it along. To make the phone call, where is it now? Why is it taking so long? You got to use everything that you have in your box of cards to make things happen. Okay, this is some of the work that we had to do. It was in conjunction with some funding from the Department of Energy to say, in this location off of east of Dania Beach, what are the prime areas that we want to go after? And if you will notice, I don't know if I can show it here. Is this a laser? Okay, so. Thank you. If I put my glasses on, and it's there. Okay. If you look at this area, this is off Fort Lauderdale, Dania Beach, and the area of interest for the actual survey that was conducted by the Department of Energy are the bottom two blocks of the 3 block. There's one other one up here. The 3 blocks that we have in the application of the lease. But in looking at that survey work, this is the easternmost boundary of that block. This is an area to stay away from because this is a whole within an area called a coral habitat area of particular concern. Deep water corals, they were just identified within the time frame of when we submitted the lease, so we had to deal with that, or the application. But you want to stay away from that because that's a prime habitat area for coral and other marine life to establish that habitat. So we stayed away from that. We're in this area, and at the same time we have to consider these light green areas there's more sandy area. It's a better positioning for putting an anchor in the seabed floor, and we're staying away from the marine life. So we're going to have to do additional survey work, but this helped us to determine, along with some of the other uses in that area, like fishing, vessel traffic. The Navy has sensitive acoustic systems in there. There's submarine traffic, corals, and other marine life that are sensitive in that area. So we had to consider a lot of this in putting together our application. Okay. I mentioned marine life. We've conducted 2 years of aerial surveys. There's a lot of information about sea turtles and their endangered species along the coastline. We know a lot about that. We know when we have to dim the street lights, et cetera. Hardly anything is known really about the cross-stream migratory patterns. And so we're working with scientists at FAU to determine those patterns. Being an endangered species, it may not be a real issue for our putting one device in the water, but when companies start putting in arrays, they're going to have to think about this. How do they detect? How do they minimize those impacts? And what is the policy at that point of acceptance? And since they're endangered, that's going to be a difficult policy to deal with at a federal level and state level. I mentioned the corals. One of the questions is that when you put in an application, you have to have a decommissioning plan at the end of your lease. So it begs the question, have you really established with an anchor down there a new habitat? So are you doing more damage to pull the anchor up and disturb a habitat that's just been established? Or do you leave it down there and allow it to continue? That's a policy discussion that has to happen with with NOAA and their policies and procedures. So we're getting into state policy and regulations, we're getting into federal policy and regulations, but again, blazing the trail for companies as they move forward. Let me show you a little bit about our technical approach. We're doing the ocean current resource characterization. We've had acoustic Doppler profilers for periods of time that have been deployed in the ocean, and that measures our current speed. Our first set of ADCPs, unfortunately, one of them let loose of its mooring. We ended up actually, if you saw a press release recently, ended up finding through an email that a fisherman in the Azores had found an ADCP. It's the ADCP is an instrument, but the mechanism that got it there is this syntactic foam buoy that flowed along the current and made its way in 3-year period to the Azores. We got the data back, and so the importance also of that is in any aspect of engineering, if something is not working, you determine what is the appropriate procedure to fix it. And so since then, we have tracing or tracking systems on our ADCPs. If they happen to let loose, we know exactly where they're located. There's a lot of work ongoing now for turbulence characterization. It's important on the inflow of the current to understand if there are turbulence aspects for the designers and the developers. So that's research that's ongoing right now at FAU. By the way, as far as research goes, we've been able to thankfully provide funding for over 40 graduate students and PIs at the university, as well as some of our collaboration with other universities working on this bigger picture. That is going to be a challenge in the future, and as companies develop their designs and test them, that's where we see a lot of opportunity for company investment into research. Right now, a lot of companies are not at that point, including the companies that are, 2 people in a shop. They have a design, they build it, they put it off their dock and determine that they've tested it. Well, there's a lot of risk in that. But they also don't have the funds to invest in significant amount of research. Hopefully, as in others, I think you were mentioning about collaboration, I think, and an earlier presentation about industry getting together and looking at those really sweet spots that are not necessarily intellectual property. It's a big picture. It's how they apply that research to their designs and their plans, which makes it their intellectual property. So work together on that bigger collaboration. We also have a demonstration turbine. It's a very straightforward, single axial, 3-bladed rotor, if you will. And it's the test berth itself, and I'll show that to you in a subsequent slide. The test berth itself is, as I said, off of the coast of Dania Beach, Fort Lauderdale. The aspect of the whole regulatory process was actually to put an anchor in the water, in the seabed floor, but you had to wrap all the environmental concerns around it. This actual picture that you see here is a layout of what the test site will look like. So there will be a mooring buoy, which you see on the bottom right-hand picture, that will be anchored out there through the term of the lease, which is 5 years. It will be brought back at some point in time for refurbishment. It's not only going to be addressing and assessing the resource on a continuous base, but also the environmental effects and seeing what's happening with the marine mammal, the marine science around it. It is an opportunity for doing a lot of other research, scientific and technical, so it's a platform where you can define a new instrument, you can be able to test it out there for long periods of time in the environment. A vessel of opportunity will then take, in our case, it'll be the turbine, take it out there, it will tether, hook up to the buoy, which is anchored to the seabed floor, for periods of time, either a couple days up to a week, depends on the test plan for the company, and in our case, it would be our first testing. Our testing is to prove out the feasibility, to prove out the protocols we've put in place, to establish the credibility for companies as they come with their devices. And we have companies from around the world now that are looking, 7 or more serious. And one of those is from Italy, and then we also have interest from South Africa and Japan just recently through a company over there. And this is a look at our turbine. We actually just finally got funds released by the Department of Energy, which was being held up until the environmental assessment had been released. And so we just conducted the tow test that operated very well. We incrementally stepped up the speed in half knots to get it to a point where finally, when the turbine blade was unlocked and available, free to spin, then it started spinning at about 5.5 knots after the seals were broken in. There was not a generator in it at this point. We wanted to see how it operated when it was being deployed, and also when it would actually start spinning as far as the rotor goes. It operated well. The mooring buoy you saw in the previous picture was also tow tested in its final tow test. It's been through 3 tests. This last test was after we had actually stretched that Cadillac. So it brings it back to the land, if you will, in terms of terminology, but we had to add more buoyancy, more ballast. We actually grew that so that, and blunted the forward of it, so that instead of punching through the waves, it actually rode the waves. And we were out there in 10 to 12-foot swells, and it operated well. It has to be out there and be able to operate in Cat 4 hurricane. So these tests were extremely important from a validation and verification of the design and the capability and the handling. I mentioned, in a previous slide, it's a TRL. This is where the ocean energy industry is today. Wave and tide are much further along in what they call a technology readiness level scale. This is a scale that shows government, funders, industry, academia, a maturation of research and technology. And the bottom being a back of the envelope napkin concept idea all the way to a level 9, which is where you get into final production, commercialization. Wave and tidal are further along because they also benefit from the fact that the European Marine Energy Coalition set up a test site over on Orkney, and they've been testing since 2006. And somebody said something about investment, huge investment. UK has its problems, but they have a very definite plan for energy as far as renewables go, and they have invested heavily in the marine renewable sector as well as offshore wind. Okay. We are at, ocean current is about a level 4. We can probably move that up now to at least a level 5 since we've done some tow testing of our own device, but the industry itself has quite a ways to go, and they need to start doing their testing. So that's where we are now, is to put in a nursery site, test site off of Florida. The plan then is to go to a prototype test site in a more benign area, again off the state of Florida. So we will have the nursery site for those very small scale early designs, getting through the rudiments of testing and evaluation and validating not only the design itself, the modeling and tools that go behind it, and take it to the next level. This is the plan that we've promoted all along, and part of it is coming from other industries and knowing how you need to move through those steps of early testing and validation. Otherwise, you get into where the early aerospace was, where things were tested in full scale, and you've got wings that were collapsing on each other. And believe me, the designs that are out there right now are not just single axial turbines with blades. Some are looking like helicals, some are looking like the old design of a lawnmower. Okay, so you've got ideas all over the map, and you've got companies that are well established in their design process. The Lockheed Martins, the Siemens, et cetera, but you've also got companies that are 2 people in a garage, and great design, great ideas, but the whole process isn't there. So we're working as a university, both at the regulatory framework with the environmental science and working with our collaborators. And I think, okay, as we go to full scale or the next size of testing the prototypes, we've really got to start thinking about the transport to the site. That's to the connection with the distribution centers, we've got to look at the deployment of the devices of the large scale. The communications and control, that's where you start putting in the arrays. So if you're detecting a marine mammal, a whale, how do you function? How do you work? Also, how do you understand the life cycle of the devices in the water? This is going to be a real challenge for the marine renewables, especially when you go into the ocean current, because you're talking about depths that might be 200 meters to 800 meters, depending on where the location is around the world. So O&M is going to be a big issue to deal with, as well as the cost, and still struggling with that because we need to understand all these other factors that go into it. But the cost wrapped up in that is also the transmission line to shore. And that can be anywhere from $1 to $3 million a mile for cabling. So this is where the cost gets into it. But there are some research ongoing right now to figure out how to do that networking, and it's building off the back of offshore wind. And I think that's it. Jay, thank you.
So you got to take a question at least. I know we're a little late.
Okay. Yes, Andrew.
How far out on the coast are you having to go to be able to come?
The closest area, the current, if you look at the Gulf Stream, it hugs the coastline up till West Palm Beach and starts diverging a little bit. But we're going to be out, our site is located 10 miles off of the coastline. Some of the other, if you look around the world, like the Agulhas Current, the Kyushu Current, there's some closer proximity there, but then you're dealing with deeper waters in some cases. We're also working with North Carolina because they're looking at the ocean current, which is the same body of water that we have right now, or the same current, and looking at how they can possibly harness that because they've evaluated wave and tide, and that doesn't seem as good. Does that answer your question? Okay. Yes, sir.
What is on the ebb and tide, are they talking about fluctuation? I mean, because sorry about that. On the ebb and tide, as you said, it's getting ready to go into production. Are they actually looking at the fact that with some of them, are they going to be able to go into such as sensitive areas, such as small tidal areas that would be able to fluctuate, let's say, rise and fall of like 3 feet or something like that?
Well, there are some companies like Verdant right now that are working up in the East River that are looking at more the tidal energy. So they're focusing in that area. So they have to deal with that all the time. Florida is, as far as being able to use tidal aspects, it's a little more difficult. And our tides are not that intense, like you off of the Orkney area or even the Bay of Fundy. Those are huge tides compared to what we have here off of the coast of Florida. So yes, they are dealing with it, but in the other centers as far as testing, Washington State is working with that too. A lot of this information, I have my website, which I had on the corrected version. That's not what we got up there, but that's okay. The research, the publications is all available. It's all publicly available. And the abstracts, if you will, of the theses and dissertations of the students, as well as connection to the other universities and laboratories. I know that's a longer answer to your question, but okay. Does that help you? Yeah. Okay. Thank you very much.